Hi students, this is Mr. Yao. In this lesson, we're going to continue to learn more about exponential story problems. But quickly, let's review what an exponential function looks like. F of x equals a times b to the x power plus c, and b has to be greater than 0, and b cannot be 1 because that would make the function a straight line. B is called the growth or decay factor, which actually represents the ratio of the final amount compared to the original amount, and we can write it as a decimal. There's also something called the rate, and this is where you need to be able to tell the difference between a factor and a rate. Factor is this number specifically, which is again just the final amount divided by the previous amount. But rate actually represents the increased or decreased portion, the specific increase or decrease portion compared to the original amount, typically written as a percent. So let me quickly draw a diagram. Let's say this is the original, and if we have some extra on the top, this extra portion would represent the rate, but this whole thing is going to be the factor. Or the other way, let's say you have this as the original, and you cut off some extra. This is the rate, but this is going to be the factor. So that's the difference between rate and factor. Rate is just the changed part, changed portion. Factor actually represents the whole thing. So when it's increasing, we have growth factor and growth rate. And factor is going to be 1 plus the rate. So the 1 again represents the 100%. We have talked about in the previous lesson. So this part is the 100%. And let's say you raised up, it went up like 8%. And that would make the factor 100% plus the 8%. That's growth factor and growth rate. When it's decreasing, we have decay factor and decay rate. And in that case, factor is going to be 1 minus the rate. So in the previous lesson, if you remember, let's say this whole thing originally was 100%, and instead went down 15%. That will keep the factor as the leftover 85%. If not specified, we always round to 2 decimal places. Now let's see how the factor and rate work in some examples. Example 1. The price of an iPhone is $800. Utah's sales tax rate is 7.25%. What is the total price? Sales tax is typically on top of the price that you still have to pay, so that is going to be extra, which means that is going to be growth. The rate is the changed portion, so the rate itself is the 7.25%. Now, in order to calculate the factor, we need to change that rate into a decimal, which is 0.0725. And since it's growth, that means the factor is 1 plus the 0.0725, which is 1.0725. So that's the factor. But when we actually calculate the final, remember it's a times b to the x power. The b typically is already the factor. So we're going to always use the original or the initial value multiply with a factor. So it's 800 times 1.0725, which is going to give us $858. Next, now we're seeing this example again. $340 to begin with went down means it's going to be decay. The percent it went down is our rate, which is 15%. And 15% is 0.15 in decimal. Because it's a decay, so it's going to be going down from the 100%. So it's going to be, you have 2 different ways to calculate the factor. So one way is what we did in example 1, or you can use 100% and subtract the 15%, which leaves out 85%, and rewrite it into a decimal, which is 0.85. So in other words, in the previous example, you can also choose to calculate 100% plus the 7.25%, which is going to give us 107.25%. And when you rewrite it into a decimal, it's 1.0725. That also works. Now to calculate the final, it's always going to be the original price multiplied with the factor. So it's 340 times the 0.85, which is going to be $289. That's example 2. Example 3. Earned 25% interest on the investment. Interest typically is on top of the original price, so you earn extra. That means it's going to be growth. And the extra part, which is the interest, is your rate, so 25%. And to calculate a factor, because it's growth, so it's going to be 100% plus the extra 25%, which makes it 125% or 1.25 in decimals. Final is going to be 1,000 multiplied with our factor, which is 1.25, which makes the final $1,250. Example 4. Ashton invested $1,400 in a company. After 1 year, he has 80% of the original investment left. That's where you gotta be careful. He has, it didn't say it goes up 80% or goes down 80%. It says he has. So that is actually a result. The result is gonna be the factor. If he only has 80% left, that means it's decay. And the tricky thing about example 4 is this 80% is actually our factor, which in other words, that is 0.8. If the result is 80% compared to 100%, that means our rate is going to be 20%. And it actually goes down 20%. Final is going to be 1,400 times 0.8, which is $1,120. Now let's continue. Example 5. The A company's portfolio is worth $15,000 and multiplied by a factor of 1.75. So we already know the factor is going to be 1.75, which is more than 1, so it has to be growth. The rate is always the factor compared with 100% or compared with 1. So 1.75 compared with 1 is extra 0.75, so in other words, extra 75%. To calculate the actual value, that is 15,000 times the 1.75, because we always multiply with a factor, and that is $26,250. That's example 5. Example 6. A population number 20,000 initially grows by 8.1%. So that is going to be our factor. That is going to be our rate, is 8.1%, which makes our factor 100% plus the 8.1%, which makes it 108.1%. So the factor is 1.081. Initial value, well, it started with 20,000. So our function p equals 20,000 times 1.081 to the t power. There you go. Now you can see how it works, how it transforms into an exponential function. That's example 6. Moving on, example 7, which works in very similar ways as example 6. So you start with 4.3 trillion, growing by 8.7%. So this is our rate, which makes our factor 100% plus the 8.7%, which means it's going to be 1.087. So to write the function, p of t equals 4.3 trillion times 1.087 to the t power. And then use this equation to predict the GDP of China in 2012. 2012 is going to be 4 years after 2008. So basically that means p equals 4. So you are actually trying to calculate g of 4. So it's plugging in again, 4.3 times 1.087 to the 4th power. That would, after putting in the calculator, that's going to give us 6.003, so it's going to be $6 trillion. There you go. That's example 7. Example 8. The population of endangered species of tiger is currently 500, and the population is declining, so going down at a rate of 7%. So the rate is 7%, which makes our factor 100%. Since it's declining, means we need to subtract the 7%, which makes it 93%, or in decimal is going to be 0.93. So to calculate the population, p equals, started with 500, so a is our initial value, and b, our factor is now 0.93 to the x power. And that's how we set up the function. That's example 8. And that is everything for the second lesson of exponential story problems. Thank you.